Hello everyone, in this video I am going to explain the complete analysis of magnetic flux, induced EMF, and the steady-state current in a simple motor. I will walk through the geometry of the loop, the magnetic field, how the flux is calculated, and finally how the induced current is obtained using Faraday's law. Section 1. Geometry of the loop and magnetic field. We start with the physical parameters defined by the values a, b, and y. Using these numbers, we calculate the radius of the loop, its area, the magnetic field vector, the number of turns, the rotation angle, and the angular frequency of the motor. This gives us all the components needed to determine magnetic flux. Section 2. Magnetic flux through one loop. Magnetic flux describes how much of the magnetic field passes through the surface of the loop. It is given by this formula. So when the angle is constant, the flux is also constant. Section 3. Time-dependent flux. In part B of the problem, the motor rotates, meaning the angle changes with time, described by this formula. So the flux becomes into this. This allows us to calculate the flux at any moment, such as at 0 seconds, 10 seconds, or 60 seconds. Section 4. Induced EMF. Faraday-Lenz law. A changing magnetic flux induces an electromotive force, or EMF. According to Faraday-Lenz law, for our rotating loop, this leads to this. When the sign turn is 0, the induced EMF is also 0. Section 5. Steady-state current in the motor. To find the current, we use this equation. At the time t equal 14 seconds, the induced EMF becomes 0, because the turn is 0 for this particular value. So the current is simple. With a 9-volt battery and a resistance of 100 ohms, the current is 0.09 amperes. In conclusion, we calculated the geometry of the loop and the magnetic field. We obtained the magnetic flux for a constant angle and for a rotating loop. We used Faraday-Lenz law to find the induced EMF, and finally, we determined the steady-state current using Ohm's law. This analysis illustrates the fundamental principles behind how a simple motor generates and responds to magnetic induction. Thank you for watching.